Okay. So this has a phase shift. What's the center line of the wave? 0, right? There's no changing of the center line of this wave. The phase shift, however, is what? Be careful. Which way are we moving, left or right? Moving to the left. That is a negative pi over 2 shift, folks. Just remember, you have x minus h inside here. X minus h. And that's how we end up with our negative pi over 2. Anything going on with the amplitude and period? Nope. Same old, same old. 1 for the amplitude, 2 pi for the period, because it's a cosine function. Now, where is HK?
0.
Isn't it over here? That's HK, right? Negative pi over 2 comma 0. And we know to find the first point on a cosine wave, is it actually that location right there, or do I have to use it and go up from there? You have to go up. And we're only going up 1 unit, right? So there's point number 1. How far to the right should I move before I find another place where it repeats this cycle? Well, you told me that nothing changed. The period was still 2 pi. Therefore, we move 2 pi units to the right. Now, before you get all crazy on me, please don't go to here. That's too far, isn't it? Each one of these blocks right here that I'm highlighting is pi over 2. How many of those blocks do we need? 4 of them, right? So the correct location 2 pi units later was right there. Yes, question? Probably. I don't know. I mean, are you saying it's hard for you to, like, go pi? I understand it's a lot easier if you have the scale drawn for you. I'll have to look, but I think they are drawn for you. Okay? So that to speed up the process of the test. Because, yes, another question. Okay, let's ask a real question. Okay? You will take part of the test. Of course. The left part. Okay. So, that's point number 2. Where's point number 3? Where do I need to go from here? Back to the middle, and then what? Down, right? Using the amplitude to find that lower portion. That point down there, and then, of course, I need point number 4. And I have no idea why it's doing this today. I might have to shut this thing down because it's like, you know, breaking apart my numbers. Next thing you know, my cosine wave's going to be, you know, in pieces. Oh my goodness, look at that. Look at this. Okay, it's not my fault, folks. I might have to, I don't know. Okay, all right, very nice. So that is how you deal with a phase shift. Find HK. After you find HK, you just have to use the amplitude and period to find the other points. Just like we've done before. Any questions on that? All right. Let's do a simple sine one, and then we'll move on to something more complicated. All right. What's the center line of the wave? 0. Okay, so we know that the vertical shift is 0. What's the phase shift? H. Phase shift. Careful. Right, that H is negative pi over 4. Oh, gee, Christmas, I'm going to get mad at this thing. Then it won't let me erase. What? Frustration. There we go. These are going to be the ugliest videos ever. Okay. Alright, so what's my amplitude and period? Same, right? 1 and 2 pi, they haven't changed because it's a sine function. We've had no stretching or shrinking in the vertical. We've had no stretching or shrinking in the horizontal. And definitely no reflections. Okay, so HK. Where do I go to find HK? 0, negative pi over 4, so you're telling me it's on this axis right here somewhere? Oh, negative pi over 4, 0. Oh, okay. So, like, right in there. How did I do that? With my finger. Okay. Sorry for being a smart aleck, but negative pi over 4 is right there, and a 0, right? Comma 0. I just had to go to the left, but not, you know, not a full pi over 2. Okay, it's a sine function, so how far to the right should I go before I find a place where it repeats the pattern? I want to go 2 pi units to the right, but folks, I need you to realize that it's going to be right there. The distance from here to point number 2 has to be 2 pi units. And if you moved this location over pi over 4, wouldn't you do the same thing at this end? So that kind of helps you understand how it's shifting over. Halfway in the middle, where are you at? So there was point number 1. We got point number 2. Where's point number 3? It's another x-intercept, right? Since this is a sine wave. Halfway in between point number 1 and 3, we go up. And halfway in between 2 and 3, we go down. Yes. I hope so. Okay. I really do. I don't wish... All right, now, let's finish graphing this thing so we can move to the next question. And mostly hit it. Okay, so everything got shifted pi over 4 units to the left. Thank you. Yep.
K is equal to 0 when it's sine, but then it's equal to 1 when it's cosine.
K is 0 based on what you see out here. Okay, that's the vertical shift up and down. And since we don't have anything being added or subtracted, we know that it's 0. Now, is HK on a sine wave? Yes. HK is not on a cosine wave. It's underneath the maximum, right? Okay, so it's important to find that point HK, but then you have to remember, is it on the wave or not? Because inside these parentheses, we have x minus negative pi over 4. On the street, they call that x plus pi over 4. But to you and I, x minus negative pi over 4. So your phase shift is this part right here. Okay? Because it's always got to be x minus. Fireproof form has that x minus h. If it was x minus pi over 4, then my answer would be positive pi over 4. Yep. Okay, let's find something more difficult. Maybe we can, ooh, this is a good one right here. Is that, yeah, let's talk this one. Number 5 on worksheet 3. Before you get all crazy on me, let's think about what we have inside there. Whoa, let me lock it in place. 2x plus pi over 1. I wanted to say 1x. So what am I going to multiply the top and bottom by so that I change this from a 2 to a 1? 1/2. And if I do it to the top, I must do it to the bottom. What will you get? On the bottom, yes, you get 1/2 on the bottom. What do you get on the top when you distribute the... You get x plus what? Don't you tell me pi. Pi over 2, thank you very much. That's why we have to distribute it to both. That's why if you said to me that the phase shift was negative pi for this question, you would be wrong. Okay, question. All right. You don't if you know that you can factor out a 2. Sorry, that's a really bad looking plus sign. Man, if you can factor out a 2, which most people struggle with, and then say, okay, division by, or multiplication by 2, which is, that's a really ugly looking 2, and then is the same as multiplying by 1/2, if you can get it to there just by doing algebra, you know, this is what the math teachers want you to be able to do. They want you to be able to pull the 2 out and then realize that I can get rid of that, and instead of multiplying by 2, I'm dividing by 1/2. But most of you don't see that little trick. So my suggestion to you has been, think about what you would need to distribute to make that 2x become a 1x. Because 9 times out of 10, you guys get it right when you think about what you need to multiply the top and bottom by. And if you try to do it the old Algebra 2 style, there's a lot more mistakes that happen. So I'll get rid of that. Yes. A non-1 for a number, yes. Okay, so what's my center line to this? 0, because nothing's being added on or subtracted on the outside, so we're still centered here. What's my amplitude? Still a 1, right? Because there's been no vertical shift. You know, right now we're looking at y equals sine. Man, this is going to frustrate me to death. Next problem I'm changing, man. I'm going to shut it down and start it back up. Frustration. Don't ask me why it's doing this. Okay, so this is what we're looking at. There's no change on the vertical. We're still over 1, so we've got the same amplitude of 1. What is the period? Because it's been shrunk. We got a shrink going on right there. 2 pi times the absolute value of the multiplier does give me 1 pi. You're right. And what is the, oh yeah, you guys told me the vertical shift was 0. What's the phase shift? Negative pi over 2. If I had not done that little multiplication thing, I'm going to guess I would have said negative pi and been wrong. So we find HK. All right, so that's negative pi over 2, 0. Is that location on my wave or under the max? Is that location on my wave or under the max? You think about the function you're dealing with, and the correct answer is on. How far to the right should I go before I find another place where it starts the cycle over again? How far? Pi. Okay, so that's pi right there. The distance from here to here is only pi units. Indeed. Well said. Halfway in between, back at the center line. Halfway in between the first two, I go up. And halfway between the second two, I go down. And then we draw the wave. Yeah, we need to try to shut this down. We'll pause for station identification. This is the all Trig network. Okay, so what do you multiply by to get this to transform? 1/2, okay? So if you do it to the top and do it to the bottom, you end up with x plus... No, don't have time for that. I'll have to do it between class periods. X plus what? What do you get when you multiply pi over 4? Okay? I'm telling you, if you can do this, you will easily see things like the phase shift, and you'll be able to identify the period and say, oh, it's 2 pi times the absolute value of 1/2. If you don't use this trick, you're going to get stuck, and you will you'll be putting down the wrong information. Yes.
I have a question. When you're explaining it, like you just take the 2 out and you get that, I don't understand how you get the 1/2.
Okay. That particular algebraic skill is no different than me saying that division is the same as multiplying by the reciprocal. That goes back to our junior high days, the keep change flip thing. So if you want to say that you're multiplying something by 2, that's the same thing as saying dividing by 1/2. So in other words, I can look back here and say 2 times x plus pi over 4 all over 1. Or I can say that I'm going to divide that x plus 4 by, or x plus pi over 4 divided by 1/2. Those are equivalent statements. Most people don't make that connection in their mind, so that's why I use this idea over here, because it just works really well. Most people get it. Okay, I'm going to give you just a few seconds here to try to put this in fireproof form yourself. Okay, don't you dare give up. Okay, start with the -4. All right, that's where you should start, and then after that, deal with the 3. Okay, and then work on the parentheses. Okay, but get it into fireproof form. Take a few seconds to do that on your own, even you fans at home, because in that form, you easily see, and you can call it whatever you want to call it. We termed it the fireproof form only because it's really hard to mess it up. Once you have it in that form, you can easily pick out A, B, H, and K. You could tell me what the vertical stretch and the horizontal stretch or shrink, and you could tell me whether it's moving left and right and up and down. Now, I do understand that when you look at it in the form that it's been given to you in, some of the information you can pick out very quickly. Like, you could tell me that the whole thing's been shifted down 4. You could tell me that the amplitude has to be 3 because it had a vertical stretch of 3. The part that people get confused about is what happened to the x. They do not look inside here and understand what happened to the x. They get very confused. So they're good with what's going on with y, but this is the part they really need to focus on. And so that's why we spend more time thinking about, okay, it's 2x minus pi. What am I going to multiply top and bottom by? Obviously, I'm multiplying by 1/2 top and bottom. So this whole thing turns into y plus 4 all over 3 equals the sine of x minus pi over 2 divided by 1/2. If you wrote this as your fireproof form, you are correct, okay? But you can easily pick out the rest of the information that you need. In fact, why don't you graph it? You have all of the information. Give me the center line at least. What's the center line of this wave? -4, right? It's been moved down 4. So just to kind of, I didn't mean to write on it, so let's get rid of that. So the center line of my wave is at negative 4. Okay, where's HK? Where is HK? Positive pi over 2, right? Because it's x minus. So we've got positive pi over 2. And you guys told me that the vertical shift was negative 4, so I'm going to circle the point, pi over 2, negative 4, and see if you can do the rest. You have the equation in front of you, so graph it. Yes, it's sine. Question? Yeah, well, compare with your neighbors, because they're smart people too. They are. They are, man. So let's see here. HK sits on the wave. It's got a period of pi. What's the amplitude again? 3. So it probably looks like that. All right. It's been shifted to the right, pi over 2. So that's where we have our HK in that location, since it was a sine wave, was actually on the curve. Pi units later, we were repeating the pattern. Oh, I didn't want to do that. All right, let's find another good one here. Ooh, what's a good one? That's still a sine. Let's find a cosine. Yeah, let's get a cosine with it. Ah, here we go, number 7. Let's put it in fireproof form. Yeet. Did you say yeet? Timber! Thank you. All right. It's more like motocross, you know? Yes. He has to shift gears. Okay. But the good news is you got it all out. Okay, so what do I do first? Yep. Give me a little bit more than that. Y plus 1 over 1.5. All right, so we got that taken care of. Now I got to think about what goes inside here. We got 2x plus pi over 4 divided by 1. What are we multiplying the top and bottom by? 1/2. Okay, all right. We're multiplying by 1/2 so we can get rid of that and make it 1x. We're really hoping we get 1x in there. What else goes in the top besides 1x? Pi over 8? Yes, it is pi over 8. You are correct. So that's my fireproof form. So now, what's the center line of the wave? Center line of the wave is -1. We have shifted it down 1 unit, which I'll have to zoom in for because I can't do it with my big fat fingers on a tiny graph. Okay, how about my phase shift? Phase, that's the H. Close. -pi over 8. Right, remember x minus? How about the old amplitude? 1.5, because we had a vertical stretch by 1.5. Okay? And the period. What happened to the period? Is it stretching or shrinking? It is shrinking by 1/2, right? The good old shrink. So we've got the period of pi. Okay, with all that given information, graph it. We are shifting down 1 unit. Yep. It is a vertical shift by -1. So, left. So, what's halfway between 0 and -pi over 2? That's -pi over 4, which is not what I'm interested in. I want half of that, which I don't even think I did a good job of marking that one. So that's the tricky part here. Oh man, it's better, but it's not the best, okay? No. So negative pi over 8 is this first mark. It's like I'm going a quarter of the distance in the negative direction. So right there is my HK point. All right, let me get rid of some of this other crap. Is that point on my wave or under the max? Is that point on my wave or under the max? Under the max, right? Because it's a cosine function. So what was my amplitude? 1.5. So that means I'm going to go up to about right there. All right? Up 1, or did I go up? Yeah, I did a good job. Thought I went up too far. Okay? So how far to the right should I go before I find another place where it starts over again? Ah, yes. Pi, and we want to go just a little bit in front of that. Somewhere right about in here. So that distance from there to there is pi. Halfway in between, right? For my third point, where do I go? Is it the high value? Is it the middle line? Is it the low value? Oh, I got to go down, right? So it's like negative 1.5, so it's somewhere right in there. Folks, because the scale is not perfectly designed for this, I mean, obviously between each one of these is 5 marks. They're basically every one of these marks is pi over 10. But I got to deal with pi over 8, so I'm doing the best I can. And that's what I'm going to do for you. If the scale doesn't look great, but you know you're right, then I'm going to be a little flexible on the grading. As long as I can see, oh, hey, did this kid, first of all, do you have it correctly identified as left pi over 8? And then, you know, obviously this is negative pi over 4. Did you do the best job you can at trying to cut that in half? I can live with it if it looks like it's a little bit off. Okay? But it has to basically be in the right spots. And then these 2 points in between so you can draw your curve. I can be somewhat flexible on that, so please make sure you understand that. Whoa, don't move on me. What's going on here? Why is that moving? All right, based on the fact that you see that it goes through the origin, would you say that's a sine or cosine? That's a good sine function, all right? So we can start thinking about, you know, at least we know it's a sine function. What's your HK? Looks like 0, 0 to me, right? Now, could I have said that this was pi 0? I could have said it was pi 0 because I wouldn't be wrong. Because this thing goes on forever, ever, ever, in both directions, never stops. There's actually some flexibility in the answer to this question. Now, what's your amplitude? 3. Now, I wouldn't care if you put this in fireproof form. If you decided you were going to put y over 3 equals sine of, now, what's the period? Period looks like what? Period looks like pi, so what does that mean about A? What does that mean about A? It's been a shrink by 1/2. Bye now.